We're continuing with section 4.1, just talking about linear inequalities, systems of linear inequalities. And here's another example. A farm co-op has 600 acres. That's supposed to be 6,000 acres. Available to plant with corn and soybeans. Each acre of corn requires 9 gallons of fertilizer and herbicide and 3/4 an hour of labor to harvest. Each acre of soybeans requires 3 gallons, making sure I didn't mess up, of fertilizer and herbicide and 1 hour of labor to harvest. The co-op has available at most 40,500 gallons of fertilizer and herbicide, and at most 5,250 hours of labor for harvesting. The number of acres of each crop is limited by those available resources or constrained, and we want to write a system of inequalities that describes this. So let's let X is going to be the number of acres of corn, and Y would be the number of acres of soybeans. I know a lot of people tend to go, it's not important to write that down. It really is. You want to know what each variable represents. So we've got several things that are going on here. We have the total amount of acres is got to be, we only have 6,000 acres to plant. So the total acres is one constraint. So the acres of corn plus the acres of soybean have to be less than or equal to that 6,000 acres available. The next thing we have going on is we are limited by how much fertilizer we have and how much labor we have. So let's start with the fertilizer and herbicide. So the corn requires 9 gallons of fertilizer for each acre, so 9 times X. And the soybeans, it's 3 gallons, so 3Y. And we have at most 40,500 gallons. So at most, we have to be less than or equal to 40,500. Now, for the labor, let's see, it's 3/4 of an hour for each acre of corn and 1 hour for each acre of soybeans. And we have at most 5,250. Now, something else that has to be true is, this is real life, this is numbers of acres, they're not going to be negative, so X is going to be greater than or equal to 0, and so is Y. So we know we're going to be in quadrant 1, right? And we're going to have some big numbers here. I think finding the x-intercepts and y-intercepts is really helpful, especially in these real-world problems. So I'm going to make kind of a table like we did on the last one. And this first one is going to be, I wish I'd given myself more room. These are going to be my x-intercepts. X-intercepts. And then my y-intercepts. So on the first equation, my x-intercept, if y is 0, x is going to be 6,000. And my y-intercept is going to be 6,000. Okay. On the next one, my x-intercept, if y is 0, in other words, we don't plant any soybeans, we're going to use we could have 450 acres of corn. If we don't plant any corn, I could have 13,500 acres of soybeans, which we know is not possible, but we're narrowing down what we have. Now the labor, the x-intercept of the labor, I would be taking 5250 divided by 3/4 or divided by 0.75. That gives me 7,000 for an x-intercept here. And then, well, that's just going to be 5,250. So we know we're going to be in quadrant 1. Everything's got to be positive, right? Okay. So I need to go all the way to 7,000. So maybe I'm counting by thousands here. 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, and 7,000. And I need to get, whoa, up to 13,000. That's going to be way too far up. Let's kind of go in the same scale on this one. 1, 2, 3, 4, 5, 6, 7. That 13,000 one is going to be just way too crazy up there. It's going to be like way up at the top of the page. So the first line, the total acres. This line, this is the total acres. I'm going to do that one in green. So 1, 2, 3, 4, 5, 6,000 and 6,000. And I'm going to connect my dots. The fertilizer and herb. So 4,500 on the x-axis. 1, 2, 3, 4, right there. And that's the one that goes all the way to 13,000. It's going to be way up here. It's going to be something like this. Let's see. Oh, I've got another color here. Yay. Labor. Let's see. X-axis, it goes to 7,000. And then 1, 2, 3, 4, 5, and a little bit there. And we end up with these 3 lines, right? Well, if everything's got to be less than, then we're talking about this area inside all of the lines. So I also want to kind of talk about our boundaries on this one and how I could find those boundaries. Well, we could solve these systems to figure out where they're crossing. So this green line and red line, that's this equation and this equation. I can actually put them together to figure out this point of intersection right here. And let's think how we could solve that system of equations. 9x plus 3y equals 40,500. And if I take the top one and multiply by like a -3, I would get -3x minus 3y. And this would be like a -18,000. So I end up with 6x equals 22,500. X equals 3,750. And if I plug that back in, it's easiest in here. If I use up 3,750 for corn, I will have 2,250 left for soybeans. So this point right here is 3750 and 2,250. Any point in this area, any combination will fit these restrictions. Like 0 zeros right here. If I don't plant any corn and I don't plant any soybeans, that is going to fit the restrictions of how many acres, how much chemicals I have, and how much labor. But that's not the best option, right? 1,000 and 1,000 fit everything, but that may not be the best option. We'll find out that these boundary points, these like corners of the graph, are the most important points. This one would be 0, 5,250. This point is that 4,500, 0. And how would we find this point of intersection? Well, that's the purple line and the green line. So I'd be combining these two. I think I could just subtract the labor one from the total acres one. X plus Y equals 6,000. Negative 3/4 X minus Y equals negative 5,250. And I would get 1/4 X equals, was that 750? And then 750 times 4 gives me 3,000 acres. And that would mean I'd have 3,000 acres for soybeans. So that point is 3,000 and 3,000. All right. In the next one, I'm going to show you how you can use the graphing calculator to find the intersections. In class, we will also show you how to use Desmos. But we're going to use technology this time. So to use technology in the calculator, I'm going to have to solve for y. So that first equation, I'm going to subtract the 5x and then divide by 2. On the other one, so negative 2 divided by 4 is negative 1/2, and then that would be 15. All right, so in your calculator, if you're using the calculator for this, I need to turn off the plot from the last time I had it going. Negative 5/2 x plus 27, and this one's going to be negative 1/2 x plus 15. I'm going to show you something kind of nifty. If I go over to where it has this line here, and press enter. I'm okay with the color, but if I go down to line and arrow through, notice that's shading, that's got like, it's shaded up, this is shaded down. We want to shade under that graph, so I'm selecting that, and we can actually do the same thing here. Whoops, forgot to arrow over and select that and click OK. It's going to shade under both of those lines. Now I'm going to have to mess with my window a lot because mine was really messed up. But let's think about how we want to set up our window. We want our x's to start at 0, and then I want it to kind of look like a nice little square, and since I have a y-intercept of 27, let's go 0 to 30 on both our x-axis and our y-axis. Let's see how that looks. Ooh, there's the first line. Oh, there's the second line. And do you see that the shaded region is this area mixed? Now we can find that point and that point because those are intercepts. But let's do a quick sketch here. So we've got and we know we've got the point 0, 0. Let me just, and this one does this, and so I'm just sketching what I'm seeing. But the main points I want are the ones that are bounding that shaded region. Okay, so this point right here is the y-intercept of that line that was the red line. It's the lower y-intercept. So that's going to be 15. So 0, 15. And this point is the x-intercept of this other line. So let's see where that would be. Well, if I put in 0 for y, I would have 54 divided by 5, which 54 divided by 5 is 10.8, so this is 10.80. Now, how would I find the point that they intersect at? Well, that the calculator can help you with. If you do second calc, number 5 is intersect. And it asks you a couple of questions. First curve, and it shows you y1. Yes. Second curve, y2. Yes. Then it asks if you want to guess. Not important for what we're doing right now. And it tells me the intersection is 612. Again, we're going to need to find those corners for the next lesson.